Okay, this is section 8.3, trig intervals. Let's take a look at the first slide. So all of there were some of these involving sines and cosines with powers. And we have a couple of formulas or rules. I don't know if you want to call them formulas or rules. So we're looking at the powers of the sines or cosines or secants or tangents. And they're calling the powers m and n. So that's all we want to start off with, just recognizing those on the next page. And sometimes you'll see in the homework, I think the first one is sometimes you just use the power rule. But here, if you have sines and cosines multiplied together with powers, and your sign is odd, let's say you have a sine to the fifth power, and this could be anything else. So they give you some tips or rules. I guess they're not rules, they're not formulas, they're guidelines. There we go, that's a better word, guidelines. And I would have this in front of me when I'm doing these problems once again, or write this down or print this out or have this in front of me when I'm doing these formulas, when I'm doing these problems. If the sign is odd, they want you to convert the sine to cosine. Okay, that's what they're saying. If the sign here is odd, they want you to convert it to cosine, but they want you to take one of the signs out. And that's going to be your du, because if we're switching to cosine, if u equals a cosine of x, then du, right, it's going to be the negative sine of x. Derivative of cosine is negative sine. So we want to save one du. We want to save a sign for the du. What they're saying, okay, we'll take one of these powers, whatever this is power of 5, we'll take one of them and save it for the du. If the cosine, when the power of the cosine is odd and positive, we're going to try to change the cosines to sines, and we will have one of the cosines out as the du also. Take one of the cosines out of here, make it just on the side for the du, and then we're going to convert the cosines to sines, and then we'll have all sines in here to work with to integrate. And this is that trig rule or identity or whatever you want to call it, where they converted sine square x when they integrated on that last test to 1 minus cosine 2x. So this is what they used. All right, so let's try one of these problems using these rules. I mean, this is really important to have in front of you. If anybody's writing this actually down, if not, you print this out, or it's in the book in that section. But it's kind of important to look at this when we're doing these problems. So here we are looking, and if you notice, sine is, the power of the sine is odd. So we want to take one of these signs and put a sine x over here, dx. So now this is a 2. I just want to show you what you want to do. You want to take one of these signs. It's signed to the third power. If I take one of the signs out and use that as my du, then we're okay. Now, if you look at that one rule, if the sine power is odd, like it originally was 3, we want to convert the cosine, convert to cosine. We want to change this to cosine. So that's what's going to happen. I just want you to see when I hit next or whatever, it's going to show you that this is going to happen. We're going to take a sine out of here and we're going to change this to cosine. Remember, sine squared x plus cosine squared x equals 1. So if we're left with sine squared, then we have, this will change to 1 minus cosine squared x. And then you'll have the cosine 4 to the 4th power. And then you'll have the du, right? The sine x dx over here, that extra sign that we put over here. So I just want you to see what's about to happen. When I hit next. And here's where they started. They brought that sign out. Everything else, you know, that's going to be the one less. Everything's the same. Then they converted the sine squared x to 1 minus cosine. Keep on pushing the wrong one. There we go. This is still here, and this is my du. And what they're going to do next, let me see. They're going to distribute. I got all this stuff in the way. You can't see all this stuff I have on my screen. I have a lot of stuff in the way. So we're going to distribute this to the 1. We're not distributing this. This stays out. And we get cosine 4, and then cosine to the 4th power, cosine to 2nd power is cosine to 6th power. So from here, we're actually done with the manipulation, because now we can just integrate twice. We can integrate cosine 4x with this. This is that sine x dx, and then minus integrating cosine to the 6th x sine x dx. So that's what's going to happen next. You just integrate that individually. And when you integrate that individually, don't forget, when you, if I had mentioned this earlier, I had mentioned that if your u is cosine x, then du, the derivative of that, is negative sine x. So we have the sine, we have the sine x there already. We have that there already. But since du has to be negative, we put the negative there, and to even it out, we put the negative here. Same way with over here. This is the du. We put a negative there because u is cosine x and du is negative sine x. And if you put the negative there, you have to put the negative out here, and the negative changes to a positive. And then you just use the power rule. You add 1, divide by 5. You add 1 and you would divide by 7. There we go. And this would be our final answer. So using that rule, I think it helps. It tells you which ones you should convert, from sine to cosine or cosine to sine. It tells you, it depending on the power of a certain a power of the sine or the power of the cosine. It tells you that you need to take something out to use as the du. So it gives you a lot of help. So once again, that's not a theorem or anything. It was, what did I say it was? What do we call it? What did we say? Guideline. It's a guideline. There we go. So try that. We might try another one on the homework. Actually, we will try another one of those on the homework. Then in 8.3, we have, I'm not sure how to pronounce this. I'm thinking it's walleyes, not wallies. I think it's walleyes formula. I'm not familiar with this walleyes person. I know a lot about history of math. For some reason, this one just, I don't remember this one. Even when you get a master's degree in math, you learn about the history of math. And I just not familiar with this, but it's kind of a cool rule. And we're actually going to do 2 of these in the homework. If you end up with an integration, and it has to be from 0 to 2 pi, and you have cosine to a power, and the power is 3 or greater, then you just start writing these fractions down. 2/3, and then the next number is 2, 3. The next number is 4, 5. Next number is 6, 7, 8, 9, and then to whatever n is. So if you had cosine of 9, it has to be odd. Cosine of 9x, you do 2, 3, 4, 5, 6, 7, 8, 9, and you stop right here. This is where you stop. You stop at n. N was 9. So 9 minus 1 is 8. So you stop when the top is at 8. And then you multiply these together, and that's your answer. So if this was even, you don't start at 2, 3, you start at 1, 2, then you go 3, 4, 5, 6. And once again, if this was 9, wait, it can't be 9, it has to be even. If this was 8, then you'd go 5, 6, 7, 8, because if you put an 8 in here, 8 minus 1 is 7. And you see, you'd be left with an 8 on the bottom. And then you'd multiply these and you get your answer. So I'm pronouncing this walleyes instead of wally. Wallies. It might be wallies. I would think it's walleyes. And we don't have an example, I don't think, in the PowerPoint here. But we are going to do 2 of those examples in the homework. Let's see where I just did. All right. More rules to write down. Here's some more guidelines. Sorry, I keep on saying rules or theorems, and I don't want to say that. More guidelines to write down. So that's why I said this section is really kind of strange, where you have to have all these guidelines in front of you to help you get through these problems. So here's if you have secant multiplying by a tangent to a power, secant to a power times tangent to a power. If the secant is even, once again, you're going to take a secant square out, because the derivative of tangent is secant square. So you're going to take a secant square out of there, and you're changing all secants to tangents. And they show you what it kind of looks like when you do all this. Secant square changes to 1 plus tangent square. Okay, if the power of the tangent is odd and positive, then you're converting that tangent to secant. What they're saying is converting everything to secant. You see, everything will be converted to be a secant, except you're taking a secant tangent out. So one of the secants and one of the tangents are coming out as your du, because the derivative of secant is secant tangent. You can verify these all in your derivative sheet. All right. So when there are no secant factors and the power of the tangent is even and positive, oh, there's even more rules. Did I write all these down? Yeah, I did. When there are no secant factors and the power of the tangent is even and positive, convert the tangent squared factor to a secant squared factor, then expand. So take two of these tangents, tangent to a power of 2, take that out. And then it says convert it to a secant. And tangent square equals secant square minus 1. And finally, they say if you just have it, that's just if you have a secant to that power. If you just, I mean, a tangent, if you just have a secant, this is a little weirder. And M is odd and positive, use integration by parts that we learned from 8.2. So they just say, hey, go use integration by parts to do that question. And then if nothing is part of that guideline, just use some kind of a sine or cosine rule to change the trig functions to where you can find something. So you see, there's lots of these guidelines here. So this section can be frustrated, can be frustrating if you don't have these guidelines in front of you. It's really important to try to have these guidelines sitting there in front of us. Find where I just wrote those guidelines down. 8.3, then the Wallies. Oh, here. 1, 2, 3. All right. So it says, because you expect to use the power rule with u equals secant x, convert all the, oh, it says save a factor. Oh, this is from rule number, right, 3 that we just had. I don't have that sitting in front of me. See, I want to go back.
Yeah, I'm trying to print it up on my other computer to print it up right now.
Yeah. See, it's you're going to change everything to secant. The tangent is odd. In this one, it's number 2. The tangent is odd, and you're going to change everything to secant. The tangent is odd. We're going to change everything to secant, and we're going to take a secant tangent out. So we're using this rule here. I mean, even though our secant is a negative, I think 1/2 right now, but our tangent is odd. We're going to take a secant tangent out and convert everything to secant. So I just want to make sure we see that. It's, for some reason, I didn't write those down. I thought I wrote all of those down right in front of me. Those I didn't write down. So I wanted them to have right in front of me. So I want to just show you what they're using. They're using this number 2 rule, the guideline. I thought we were using a different one, but no, they're using number 2. And they bring, once again, they just bring this 1/2 up to a negative 1/2. our tangent is odd. So we're going to, what they're going to do is take one of these tangents out. So we're left with tangent square x because we took one out. And they need to take a secant out also. If they take one out, then we should, since we had a negative one, and if we subtract one, we had 3, we subtracted 1, we have 2. If we have a negative one and we subtract 1, our power now should be a negative 3/2. Okay, so this is the du part, but this is where we're at. We're integrating at this point. So I just wanted to make sure we brought this up to the top. We take a secant out and we take a tangent out by subtracting 1 from each. Subtracting 1, -1 minus 1 is a negative 3/2. Okay, so that's what's happening. It's hard to see. And sometimes, and I'll show you in the homework, sometimes it's hard to see what they do a step, but it's hard to see exactly what they did. So that's what we did here. We took a tangent out, a secant out of there. We took a tangent out of there. And then we converted tangent square to secant square minus 1. And next slide, they're going to distribute this. And negative 3/2 added to 2 ends up being a positive 1/2. And then we'll have a negative 3/2 over here when we distribute that. So we should see that on the next slide. There we go. So negative 3/2 plus 2 ends up being 1/2, and then we distribute the negative 3/2 over here. And now we should be able to integrate, separately. Now we're going to integrate secant x to the 1/2 minus secant x. Can I just write sex? Secant x to the negative 3/2. Each of these have the du next to it. And then they'll integrate that by adding 1, and you'll see adding 1 and then putting the new power on the bottom. So we integrate this by adding 1, we get 3/2, then we put 3 on the bottom, 2 on top. That's how we got that 3/2. And I did notice on the test, a couple of people had done that part wrong. And let me just show you once again. When you add 1, you get 3/2. You put the 3/2 like this. Another way of writing 3/2 like this is taking the 3 and then bringing up the 2. So, it's the same thing as 2/3. Dividing by 3/2 is multiplying by 2/3. Here, when you added 1, you get negative 1/2. So then you do a negative 1/2, and the negative and the negative changes to a positive. And we're done. Unless they do anything else to this. I'm okay with this answer. Yeah, they're okay with the answer too. I thought maybe they're going to try to bring that together somehow, or no. So do you see how the guidelines are really important to have in front of you and to use? It helps you, it helps you get through the integration. It's tough to realize at the very beginning, if your tangent is odd, oh, I have to take a secant tangent out. So you want to do that right away. That was part of the guideline. God, it won't ever let me just go back. That was part of the guideline. here for number 2. It says if your tangent is odd, save a secant tangent factor. Save that secant tangent factor. So you have to save that out on the side as your du. Okay. I think that was it. Oh, there's actually, more. Okay, so this one. If you're going to multiply sine power x times sine power x, or sine power x cosine power x, or cosine power x cosine power x, there's a quick way of combining it all into one, into where you're multiplying, you're changing it to an addition or a subtraction. And this is it. Here, let me just give you an example. If I did sine 5x times sine 3x, there's 2 sine v. You would then change this. Can you guys still hear me?
Yeah.
Can you guys
Yeah, I
hear
can
me?
hear
Okay.
Breaking up a
I got a
bit,
little
but
message
yes.
on my thing. Yeah, I
Yeah,
got a little
it's
message
a little
saying
bit.
my internet is unstable, but it should be fine now. All right, so you're going to change this to 1/2 cosine. This is, the first one is the m, the second one is the n, m and n. M minus n, 5 minus 3, which is 2. Then minus cosine m plus n, 5 plus 3, which is 8. So they have you change, sine 5x times sine 3x to this, and then integrate it. So that's how that's going to, that's how that works. Once again, something else we need to have in front of us when these problems come up. So I'm really considering allowing you guys to have 2 pages of notes. I wish I would. That would take me a long time though, to go through all the calculus 2 sections and all the guidelines, all the theorems and all that, and like type them out so everybody can have them in front of them. That would be great. So I'm thinking about having and 1 more page of notes that you guys can write down for the test, because this, if you just look at this section, it took me a couple pages to write these notes down.
What if we just screen capture and kind of like collage
Well,
it all together?
Yeah, well, yeah, but how many pages are we gonna have here?
I'll use a real small font.
Yeah, yeah.
Yeah, I feel like we can scale it down and move it into a page.
Yeah, I would do that. I think I'm gonna allow any of these formulas that we see on the PowerPoints, not the problems, but these guidelines. Yes, you can use those on the test. So if you guys do want to screen capture them or somehow, you can actually get them from your book also. Maybe it might be easier. I don't know if the book even allows you to screen capture them and then convert them over, or use the PowerPoints and screen capture them, because there's so many of them. So yeah, I will allow that. Okay, so using the product to sum identity. So once again, here's an example that we have. I'll just hit next so I don't have to write it all out. If we look at the rule, this is sine times cosine. So once again, we're going to be using this second one, sine times cosine. 1/2 sine m minus n plus sine m plus n. So we're using this one here. So we're going to have sines. We're going to subtract the first 2, and then we're going to add the second 2. So it's similar to the first one. So let's take a look at that. And once again, you subtract the first two, 5 minus 4, and you get 1. 4 equals 9. And then integrating sign gives you negative. If you look, integrating sign gives you negative cosine. Integrating sine, when you integrate sine of u, you get negative cosine u. U equals 9x, so du equals 9. So you have to have a 1/9. They put the 1/9 here. And that's, then they distribute the 1/2. So it's not too bad. I mean, this looks crazy trying to integrate sine 5x times cosine 4x. It looks a little crazy. And if you know, I think if you look through your 100 integration formulas, I wonder if this one's in there. You know, sine, cosine multiplied together. I would take a look through right off the top of my head, I didn't see it. Yeah, I didn't see it right off the top of my head, so maybe it's not in there. Once again, it's not a theorem or a rule, anything. It's just a guideline. All right, so that was that. I'm going to go to the homework now, but unfortunately, I have to take about a 5-minute break because I got to go to the bathroom. Sorry. Let me hit pause. I guess I should have did that.
You're fine. I'm doing the same.
Okay, so we're back. Can you guys hear me again? Is everybody back?
Yes.
All right. Just nobody ever left. All right. Let's see what we're doing. Okay, let's take a look just at a couple of these. Number one, it's set up for us so nicely. Number one, because we have the cosine with a power and we have the sine already. If I say u equals the cosine of x, then du is the negative sine of x. So the only thing we really need here is a negative. And so then we put a negative out in front. And we can integrate this as u to the 15. And so you add 1 and get u to the 16 over 16 with the negative in front. And u is cosine x. And there's our answer. So that's nice when it's already set up. They have the du for us already. And that's usually like that when you have the first question on something. Now, let me see which is the, did I have some problems set up that I wanted to have to do? But did particular ones. We might as well do one of those two. Yeah, let's do number 2. Okay, so sine has a power of 3. So if you go to 8.3 notes where your sine has an odd power, that's like that. that very first one, it says save a sign X. And in this case, we're not saving a sign X. We're saving a sine of 4 theta to the third power. Uh-oh. It says my internet. Okay. Shortly it said my internet's unstable. What is going on with my internet? I have a Google fiber optic. It should be the best, unless they're working on the line. All right, so that's what we're going to do. We're taking one of these signs and bringing them here, and we're going to end up with a sine squared. Sine squared equals 1 minus cosine 4 theta. Sine squared 4 theta is 1 minus cosine x plus cosine squared x equals 1. So if you want to find out what sine squared is, just take this to the other side by subtracting. All right, so we are here. Then we're going to distribute. Instead of saying square root, just say this is 1/2. And distribute 1/2 plus 2 is 5/2. Right there, there. Our 4 theta, if u equals cosine 4 theta, then du equals negative sine 4 theta. But this 4 here, right, that's the u, and so there has to be an extra 1/4 somewhere to count for that 4. There's a negative. Okay, so I was off on a tangent and I got lost. We're here. We're still here. Oh, we put the, if we put an, if we, oh, it's, if u equals cosine 4 theta, then the derivative of u is negative sine 4 theta with a 4 because of this 4. Then you take the derivative of this and you get 4. And if you put, we don't have the 4, the negative 4 here yet. Since we don't have the negative 4 here yet, we have to put the negative 1/4 out in front to cancel those out. So that's what they did here. Once again, so this is just du. So when you integrate, you add 1 and you get 3/2. Once again, 3 and then flip the 2 up to the top. 5/2, add 1, you get 7/2, 7, flip the 2 up the top. And then they distribute the 1/4, and that's it. So the hardest part is making sure your du is correct. Is that if u equals du has to be correct. That's not the correct du. So you have to make it correct, and that's by doing this to even it out on in front. All right, let's look at a couple, I think, of the wallies. Did I say wally again or walleye? I think it's walleye. I might have to look that up. All right, so here is, so I'm going to pull up my walleye formula. if we're dealing with cosine and n is odd, and cosine n is odd, we just start writing 2, 3. All you do is just start writing 4, 5, 6, 7. When do I stop? Anybody know when I stop?
When the top number becomes one less than the,
Yeah, remember the formula was n minus
Or-
1. So 7 minus 1 is 6. So we don't need these. We stop right here. And then we multiply these together. 8 times 6 is 48. Or you can do this. You can cancel that with this. And now you get 2 times 4 is 8, times 2 is 16. 5 times 7 is 35. And there's our answer. I like those. Those are nice little easy integrations. And once again, don't forget, you can only do that when you're integrating from 0 to pi over 2. And
yeah,
it's a
it's pretty
cosine.
easy, but it's not a lot of
Yeah.
opportunities.
Yeah, you might see 1 on the test. There were 2 on this homework, I think. This was just a little different. This was the even one. I just wanted to show you. I mean, they're not exactly the same, right? If you look at the even one for cosine, the other one you started at 2, 3. This one you start at 1, 2, 3, 4, 5, 6, 7, 8. And then we do 9, 10. 1 less than the 10, which is 9. And then when you multiply all this, oh, there's still more to this. By the way, this is not it. Let's go. I almost want to, is that PowerPoint still up or did I get rid of it? I want to show you there was a huge difference in those 2 formulas. Let me get back to that right here. Look at the one that's even that we're doing right now. There's an extra pi over 2 at the end of it. So I wanted to mention that also. So here we start, when it's n is even for cosine, we start 1, 2, 3, 4 and stop at some point, but then you still multiply by a pi over 2 at the end. So I don't think I stressed that when we looked at this originally. So I want to stress that now. They actually show that. Yeah, you're multiplying all the way to 1 less to 9, and then you multiply by the pi over 2. And when they did that, this is what they got. So that's kind of important when you look at the formula. The odd one didn't have that pi over 2 at the end. The even one did. And I think that's all I'm going to do. You can go. I have posted this this homework help already in the module. I posted it, I think, right before class, so you can take a look at the rest of this. Once again, there the tangent is even, so you're going to change it to a secant, if everything you want to be the same, and then it just divides out really easily. This is one of those where you have sine and sine multiplying, so you're going to just by first subtracting the 2. 5 minus 4 is 1. Adding the 2. And then integrating cosine. And then that's what you get. All right, let's go to the next section. Let me stop this recording.